Question 11. A brick falls off the top of a wall under construction and drops into a bed of sand 14.5 meters below, creating an impression in the sand of depth 185 millimeters. Calculate the speed of the brick just before impact, its deceleration in the sand. This is the first one of these questions where we've been given information about two separate parts of the journey, so we need to be careful. In the first part, we can see the distance is 14.5 meters. We know again it's fallen off the top, so the initial speed is 0 meters per second, and it's on Earth, so the acceleration is minus 9.81 meters per second squared. So if we want the speed of the brick, the final speed of the brick for the first half of the question, that's v, then we're going to use v squared is equal to u squared plus 2as. So the only rearranging that we need to do for v is to take the square root of both sides. Let's get rid of that v, otherwise we're going to get confused. V is equal to the square root of u squared plus 2as. Putting our numbers in, that is the square root of 0 plus 2 times minus 9.81 times 14.5. Now, those of you will have spotted my non-deliberate mistake. Since the movement is downwards, the direction of S and the direction of A should have been in the same. So the movement was downwards 14.5 meters. So that solves the problem we were about to have with our square root. When we take the square root of 2 times 9.81 times 14.5, we should get a value of 16.9 meters per second. Second part, so it arrives at the sand traveling at 16.9 meters per second and then slows down. So for the second part of the question, we know the initial speed now is 16.9 meters per second. In A-level multi-stage questions, if you found a value to 3 significant figures, you should use that value in the second part of the question. We shouldn't use the full value on the calculator. Second thing we know is that the distance over which it stopped was 185 millimeters, an easy unit conversion because we can just put the milli as a power of 10. So it's 1.85 times 10 to the minus 3, 185 times 10 to the minus 3 meters. And we also know that it comes to rest in the sand, so its final velocity is 0 meters per second. We want to find its acceleration A. So once again, we're going to use the equation v squared is equal to u squared plus 2as. We need to make sure we're only using these values from the lower half. To find the acceleration, this needs some rearranging. Let's go underneath. The acceleration is v squared minus u squared over 2s. That means we can put some values in of, where are we? v0 minus 16.9 squared divided by 2 times 185 times 10 to the minus 3, giving us a value of 769 meters per second squared. Once again, actually that gives us a value of minus that, doesn't it? So that's the acceleration. If we want the deceleration, that's obviously the positive value, so 769 meters per second squared.